Okay, good afternoon. Once again, I want to quickly do this to conclude the section on Matlab. We are in introduction to Matlab. Uh, this is DCE110. Went to computer aided design and drafting, and we're just in the last. We're just in the last topic. The last segment of introduction to Matlab. I'm taking the last topic here, which is learning to simulate. We're just trying to do a little of it. We can't cover everything. So I'm going to quickly do a short introduction to it for you so that you can really know. I'm sharing my screen now. Really good to see. So how do you get started with Simulink? Open the Simulink library. Uh, you need Matlab running before you can open Simulink library. In Matlab command window, enter Simulink. Now, because it takes some time before it will load, so I'm going to enter it now so that as I'm doing my discussion, it will be loading. So you will see I've just tried to test it here. So type Simulink. Okay, it's already loaded. So you can see it now because it's already loaded. And that's why it's there now. So if it's for the first time, it's going to take a long time. So like probably 5 to 10 minutes. You have to wait until it loads. Now this is the Simulink library browser, and I'm going to follow an example. This is commonly used blocks: bus creator, bus selector, constant, data type conversion delay, demux, demultiplier, discrete time integrator, gain. This for gain, ground, systems. This is one integrator, logical operator. This is multiplier. This is output. This is input here. This is input. This is output. This is product. This is relational operator. This is saturation. So if you click any of these, you will see what is inside. So you click it, then you can now do anything that you want to do. It applies to what you are doing. So we're going to see just a few examples. Saturation, scope. Now, scope, we're going to use scope, and then we're going to use, some other things that you want to, that you will come to know. Scope, we're going to see zinc, we're going to see, these are commonly used blocks. But we're going to see zincs, like this zinc, this scope is sources, okay? You're going to see sources, okay? We're going to look at sources and sinks, okay? Sources are supposed to be input, these are output, um, sources are generators, normally signal generators. Sinks are output displays that you send to other scope or to, workspace. Now, to workspace. Now, let me quickly, I want to follow, let me share the let me share, yes, my browser. I want to look at this tutorialpoint.com Matlab Simulink, okay? Now, I want to do a quick overview here. Now, Simulink is a simulation and model-based design environment for dynamic and embedded systems integrated with Matlab. Simulink, also developed by MathWorks, is a data flow graphical programming language tool for modeling, for simulating, analyzing multi-domain dynamic systems. It's basically a graphical block diagramming tool with customizable set of block library. You can use it to do a lot of things like in power, electronics, like in electrical, and a host of other almost anything that you can simulate, systems that you can simulate. Now, simulate support. Now, it allows you to incorporate Matlab algorithm into models, as well as export the simulation result into Matlab for further analysis. So these are the things you should get to know. Now, you may not need it now, but you need to have an understanding of it as you progress. Now, Matlab supports multi-system level design, simulation, automatic code generation, testing and verification of embedded system. So Simulink support this. There are several other add-on products provided by MathWorks and third-party hardware software products that are available for use with Simulink. You can use them in conjunction with Simulink. Stateflow allows you to develop state machines and flowcharts. Simulink Coder allows generation of C source code for real-time implementation of systems automatically. XPC target together with x86 based real-time system provide an environment to simulate and test Simulink and stateflow models in real time on the physical system. Embedded Coder supports specific embedded targets. HDL Coder allows you to automatically generate synthesizable VHDL, VHDL and Verilog. Now, Simul Events provides a library of graphical building blocks for modeling queuing systems. Okay, that's when you want to look at event simulation. No, district, and then district event simulation and all that. Now, Simulink is capable of some systematic verification and validation of models through modeling styles, checking, requirement traceability, and model coverage analysis. So Simulink design verifier allows to identify design error and to generate test case scenarios for model checking. Very, 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 very important. Now I want to start using Simulink now. So to use Simulink, to open Simulink, just type in the Matlab workspace. That is your command window, Simulink. When you type it, it will load this. Simulink will open with library browser. This is what is used for building simulation model. So you're able to see commonly used bar blocks, and then you pick them. So we're going to build models, just simple ones, using the example that we're going to have here. So I'm going to just follow the example here, and which I expect you to follow to and test. I'm going to see these results. Okay. Now, okay, sorry for that. I want to continue with the sharing my screen, and yes. So I just want to quickly look at this. I want to quickly look at it. So you can see here, the first thing you do is you pick a sine wave from the sources. You want to start, you begin by dragging the graph block from the library to the project window. You have sync and sources, okay? These are the two we need. Connect the blocks together, which can be done by dragging connector from connector point to the other another. Now drag the sine wave block into the model. And then this is it. And then also from sync, drag a scope block to the model. That's the scope. So I'm going to do this now, and then we now connect it. Then we'll see. So let's do that very quickly. So let me quickly share. I'm sharing the Simulink now. Okay. From sync, from sources, I drag I drag this. Okay, first thing is start new. Click on new model. Click on file, new model. Okay. Yes. This is the model Untitled. It will open. From the file, you click new. Then you drag the sine wave into the model. Yes, that is the sine wave. And then you go to zinc. You drag the scope into the model space. Okay. Now I'm trying to follow this. Let me be sure you are getting what I'm doing. This is what I'm going to do. So I want to now connect. So I've dragged this. You can see in type 2, I've dragged the sine wave and scope. Then I'll now have to connect, drag a scanner from the output of the sine wave block to the input of the scope. So I'm going to just, come back to that. Yes. So I drag. Okay, let me see if I can make it to be bigger. I want to see whether you can see it. This is my major concern, so that you can see it. Let me see. Let me close this. Okay, let me see whether you can see it here. Now, so that now you drag this output here to the input here. Okay, very, very easy. That's what I want to show you so that you can see it properly. Now, the next thing is, let me share. Okay, so I've dragged this to this now. Now, the next thing is to run by click run. Very, very simple. This is just the very basic we can do now. I'm going to click run. Then it's going to try to we are keeping all parameters at default. You can change them from information menu later. We should get the below graph from the scope. So when you click on the scope, you will get this. Yes. Let me see. This is what we are getting. Now, this is what we are getting from the scope. Okay. Now you can see. Now this is what we're getting from the scope. You should get this, which is what I want you to see. Let me see whether you're actually getting it. Okay. Let me see whether you're actually getting it. Yes, this is what I want you to see here. After running it, you see after running it, you click and you get this. This is what you get. Now this is the input here. You just keeping this constant. We can change some of these things, and as we change them, you can start seeing frequency 1. Probably if you say frequency is 10, and you say apply, you say okay, and then you run, you may see a new thing here. Okay, let's say we're running it now. Okay, you can see this is the frequency changed to 10. So it has. So when you double click on this, you can change the amplitude frequency. Let's also change the amplitude to 10 and see, and we apply it. We say okay, and then we run it, and then we click. Can you see now? Okay, the amplitude has changed. Now I can come here and say, okay, let amplitude be just 5. Apply it and say okay, and then I run it, and then you can see how it is now. So you can also, terminate this. I can say let the amplitude be 2, let the frequency be 5. let the frequency be 5. Apply it, say okay, and then I run it, and then can you see? So these are things you can do and you can get something. So I don't want to do a very long video for this because you need to start from the basic and begin to experiment with different blocks. For instance, if you want to change the bias, to change the sample time, this sample time is 1. Let's say you apply it, you say 1, okay? And then we now do this, and we now, so you can see this is what happens when it is 1, okay? So let me change it to sample time to be probably 0.5, and you apply it, and then you see what is happening. And you run it, and then you see. Can you see what happens here? So if you click next, you can look at this is what you're going to see. If you go back, step 0, what you're going to see. Now you run it. Now let's see. This is what you're going to see. So you can see. Now let me go back and change this back to amplitude 1. This one is 1 also. Change this one to I think this is supposed to be 0, and then you can see the scope. Sorry, did I run it again? Yeah, so you can see it has come back here. So that is just about that. So you can see Simulink has a lot of things you can do. You can do some analysis with it here. Model advisor, model dependency, compare Simulink, XML files, Simscape, statistical viewer. You can look at statistical viewer here and see what has happened. Can I open statistical viewer? Okay, a lot of things are happening. There's not just Simscope. Okay, there's no Simscope there. You can look at control design. You can look at design verifier. You want to check, model compatibility, and it's going to check it and look at everything. So these are the things you can actually do with Simulink. Yes, Untitled. So you see, incompatible with Simulink design, that is it. It's compatible. So you can actually know what is going on. Coverage, look at the settings. You want to know the settings, coverage for this model, Untitled. I think I need to really save it. Let me save this model first. Let me just say simple. Let me just say simple. Simple model. Simple model, okay? So let me see. Yeah. Simple model. Simulation, data display, mode, normal, accelerators. We can run, we can step forward, see what is happening, and step backward, then see what is happening, and then you can stop it. Then you can run the model, and then you can see the output. So, and here you can enlarge this, the scope setting, and I mean you can do a lot of. You can see whether this can, move further. Okay, yeah, you can fix the model in, and it will fit in like that. Okay, this is just to make auto scale. Okay, you can use auto scale, and then you can set the current as setting and so on. So a lot of things you can do here. Then you can print directly to your printer. So this is really interesting, and is really interesting. The output, this is, you can record and inspect simulation output so that you can find out what information you need to you need. And the diagram, these are the uh, diagram subsystem and properties. Display, you can set all these signal and ports and set them. Then these are the view and what will appear on your model screen. All the things you want. Model Explorer, you want to be there. You check it, it will be there, and all that. You can view a lot of things. Yeah, these are the Model Explorer. And this is what we have done for the simple model. And you can really test. This is the new model you want to start. You can edit. Then this is a file. You can start a new model. You must start from here. Then you can do the charts, and then you can also have the library. So these are preferences. You can set your preferences here. You want to the solver. You can solve model and all that. Thank you very much. On this note, say bye-bye. Bye for now. Yes, I don't want to waste time at all. Okay, bye for now. Yes, this is the model we're trying to. So what you can do, try to change this sine wave with other things. Like, for instance, if you, just that I don't have much time. For instance, if you want to, look at, want to look at another, yes, want to look at more sources. Now you may have to, change the sine wave to step of signal generator and see how it is. To pulse generator, for instance, if we drag this, I can drag this here, and then I can, delete this. I can move this here, and it is already joined. And I can, run the model. Can you see the pulse? So you can see, I can make it to do that, and I can so amplitude. Let me say probably 5. Pulse width, okay, and apply. Say okay. Let me run it. Just want to see how it is. Let me put everything in one place and see how it is. This is pulse generator. You can say time base, you can say sample base. You select sample base, you can see what it is. You can say okay, you can see sorry, you can run it and see. Can you see how it's going to look like? You can see how it look like. Okay, and you can, you can have, see how it's generating this. So you can come here also. You can say simulation time. You can use external signal. You can apply, and then you can run, and then you see okay, there is a problem. It's over time. I need to apply the external signal, which I did not apply. Let's just use simulation time. Sample time 1. Let me do 5 and see how it works. Okay, I think this should work. Okay. No, that sample time should be reduced. So let me say 0.5. Okay. Phase delay, number of sample number of samples, period number of samples, number of samples. Let me see. Okay, let me see what's happening here. Okay, yes, this is what I want to see. I want you to see this. Probably let me see how it is. Yes, this is how it is. Let me see if it can just like that. Okay, so that is all about that. I will stop here. Just to see the okay, you can see this. You can stop the log. You can reduce this. You can have this. So this is the pulses. Okay. Let's say you want to reduce amplitude to 2. Let's see how it goes. You can change all these parameters. You can see how it is now. Can you see that? So this is 2, and then it's going up. Then the number of sample 1, 2, 3, 4, like that, 5. Okay. So have a nice day. Bye bye.